users online. Really quickly, I'm just going to go through an outline here. So I'm going to talk about some of the methods that exist to track people and how heavily this is proliferated. And then I'm going to go through 4 specific things that Firefox does to help protect you, including an overview of some upcoming features that are not yet released, quick conclusion, and then I'll have time at the end for questions. And we have someone on the call from Mozilla that's helping me that will be moderating the question and answer period and will help me to answer questions asked in the YouTube stream as well. So one of the first things to understand is that on the modern web, trackers are everywhere. This chart comes from whotracks.me, and they have a extensive report that they published as a peer-reviewed paper around this data as well. And their findings were that Google tracks just a little less than 80% of web traffic online. And that's significantly more than many other trackers, but quite a few trackers exist. There's more than 400 represented in their report. They're literally everywhere. There's several different methods that can be used to track users online. Some of the most common are third-party cookies, which is a cookie that has a URL associated with it that doesn't match the website that you're visiting. So you go to example.com and it has an embedded advertisement or an embedded tracking JavaScript element that comes from, adtracker.com, and adtracker.com also sets a cookie. And how this is used is that if you go to example2.com, another website, and they also embed the same thing, they receive the cookies that have been set when the request is sent to their domain. And they're able to use that to track your browsing patterns and behavior across different sites. Another common technique is what's called device fingerprinting or browser fingerprinting. And this uses a lot of different parameters about your environment, such as the operating system you're using, the screen resolution of your device, or the size of your browser viewport, canvas information, your locale, what plugins or fonts you have installed, and other data to create essentially a unique fingerprint of your device. And there are several research studies that have been done on this, and the results are getting better over time. But in the worst case, which is comes from Panopticlick study that the EFF ran in 2010, up to 83.6% of users can be uniquely identified via device fingerprint without relying on cookies. The most recent figure is much more optimistic, around 45% of users, and that's partly thanks to mobile devices becoming more commonplace. Mobile devices are slightly harder to uniquely fingerprint than PCs are, due to the fact that PCs have much more variation in configuration. Finally, another common tracking method is network eavesdropping. And this can be used in a couple of different ways. It's not always used for things like advertising tracking. It can also be an element of malicious hackers attacking unsecured networks like public Wi-Fi in an airport or a coffee shop. Network eavesdropping is just simply anybody that has access to a network can snoop any of the plain text traffic that runs across that network, which includes things like DNS requests and HTTP requests for websites. And anything that's unencrypted and unauthenticated can be modified as well. So there's attacks like DNS cache poisoning, DNS hijacking, and modifying web page contents to insert or replace images, for instance. Why this matters is not just that these trackers exist, but that data doesn't just stay in one place. There's been a proliferation of companies which are referred to as data brokers that exist in the market, and these data brokers act to buy and collect data themselves, consolidate that data, kind of collate it, organize it, and then they trade, sell, and analyze that data. And data brokers don't just acquire information from organizations that track you for advertisements. They trade this information amongst themselves. So if one data broker gets your information, that information will soon be available to all of the data brokers. And the FTC actually did an investigation into the data broker marketplace in 2014 and found that a single data broker can have as many as 3,000 unique data segments about nearly every US consumer. The other big issue with this, of course, is that data breaches are becoming more commonplace. And this isn't just data breaches of typical companies and organizations that exist in the wild, but data breaches of data brokers as well, which greatly increases the risk profile that personal data that's collected as part of tracking browser usage online and web usage online can become known to malicious entities. Examples of this is in 2017, of course, we all know Equifax was breached, but then major data brokers like Axiom and Epsilon have also been breached within the last couple of decades, and there's many others. And why this matters is that data can be used in insidious ways. As you probably saw in the news around Facebook and Cambridge Analytica, the scandal that happened in 2015 ahead of the 2016 US presidential election, data that's been collected and analyzed can be used to influence people's opinions. This can be used to change public opinion about organizations, about persons, about policies, and about political candidates. It can also be used to discriminate against people. One of the common things that's done all over, but most well known to be done by airlines is price discrimination. The fare that you're shown when you go to purchase an airfare ticket online is different based on the location you originate from, the currency you use, the time of day, the time of week, and the time of year. What is less well known is how automated discrimination can be done in other ways. So some other forms of discrimination that are now occurring are things like hiring based on data that's collected about someone to form a social profile of that person that goes beyond what might be typically found in a typical background check. There's also now some life insurance companies that have started using like a social profile to determine life insurance risk. And more relevant to this audience, NGOs have additional risk. NGOs often work with vulnerable and at-risk clients. You might be working with refugees, immigrants, political activists, the homeless, or minorities in your community, such as people that have, non-heterosexual sexual expressions. And those people have special reasons to keep their identities protected. And as an organization, you have special reasons to make sure that both the people you employ or volunteer for you working with these marginalized communities are protected, but also that the clients of your organization are protected. And you have to be cognizant of how this tracking can be a threat vector for those communities that you serve. Additionally, a lot of NGOs and nonprofits work in highly politicized areas of work, working across international borders and working on things like human rights, social and political action, and providing cross-border charitable and humanitarian services. Because you cross jurisdictional boundaries and because this type of work has broad political implications, it can cause you to be more likely to be targeted. And this basically puts you in the spotlight and means that this type of threat is very important to your organization's success and security. Additionally, traveling carries extra risk. You cross jurisdictional boundaries. When you cross an international border, you may be subject to different privacy laws and regulations. Certain types of tracking that are not legal or are surreptitious in some countries is perfectly legal and acceptable and commonplace in other countries. Additionally, because it's the internet and it's global, those things could have global consequences for your organization. Additionally, network trustworthiness is an issue. When you're operating in your office or at home, you may trust the network that you're on. But when you're traveling, you have to make use of public networks like airport or coffee shop Wi-Fi, co-working spaces, or remote field offices that may not be active and monitored all of the time. And that provides additional opportunities for attackers to track your behavior online or to build a profile of your browsing. So Firefox can't solve for all of these risks, but it solves for quite a few of them. And so I'm going to talk about what we do to actually do that. The first thing is in our tracking protections that I'm going to cover is something called ETP, or Enhanced Tracking Protection. And this is a feature that's been in Firefox for a while, but it continues to gain improvements with the most recent release that just happened last month, containing something very exciting I'm going to talk about here. Enhanced Tracking Protection operates in two different modes. By default, it's enabled in Firefox in standard mode. And the standard mode uses list from disconnect.me, which is a popular service for keeping track of all of these things that publishes block list. And it uses these to basically provide a balance between protecting you and potentially breaking sites. but it blocks things like cross-site tracking cookies, crypto miners, and known fingerprinting scripts. We also have a strict mode. Strict mode is much more aggressive, but it has some potential of possibly breaking sites, although we're constantly working to ensure that it has broad website compatibility. And this is using a more aggressive set of lists from disconnect, but it's also doing things like blocking tracking content in all windows. And it enables a new feature called total cookie protection that just shipped in Firefox 86, which is based on dynamic first-party isolation, which I will talk more about in the next section. Another thing that just shipped recently in Firefox 85 is we now isolate network and cache state. So historically, networking was in Firefox and in most browsers for performance reasons would reuse single network connections when loading resources from the same party. This helps to save time and bandwidth, reduce connection overhead, and assist performance. But some of the trackers were abusing this by performing connection-based tracking. So they could essentially use the fact that a connection was open to track you if you visited the same site multiple times. And we also had things like prefetching that could be manipulated to all browsers have things like prefetching that can be manipulated to track you using your connection. To prevent this, since Firefox 85, we now partition these connections by the top level site being visited. This includes pool connections like prefetchers. Another common thing is to use what's called super cookies. And there's a couple of different ways that a super cookie can be set, but one of the most common ways is to set it by abusing browser cache. Image caches and the favicon cache and the HSTS cache are probably the most common caches that are abused for this. Since Firefox 85, to prevent this and pretty much disrupt super cookies entirely, we partition all of the caches by the top level site that you visited. So if you visit, say, example.a.com and you visit example.b.com, they have no awareness of one another. And even if both embed the same ad tracker, what will happen is that the cache content for that ad tracker will be completely separated from one another. So very cool and very new. Additionally, let's talk about total cookie protection and dFPI, because this builds on top of that. So basically how total cookie protection works is before there was essentially one cookie store that was shared for all cookies. And the only kind of security boundary for cookies that existed was basically the URL that the cookie was associated to. So if you went to example.com and it embedded content from adtracker.com and adtracker.com set a cookie, if you visited any site that loaded content from adtracker.com or you visited adtracker.com directly as a first party, it would receive those cookies as part of its request. With total cookie protection, we do first party isolation. So all of the cookies are associated with a first party website that you visit. So as the example in this infographic, all of these sites embed some part of the Facebook SDK, which sets a Facebook cookie. Before, Facebook would have awareness that you had visited all of these sites. But now Facebook sees a separate cookie for facebook.com, or has a separate cookie store for facebook.com from the cookie store for fuzzyslippers.com, from the cookie store for mealkit.com. And so it has no awareness of those things, and it can't track you using that cookie across those domains. But first-party isolation isn't the whole story. First-party isolation has actually been in Firefox since Firefox 55. It was part of the Tor Uplift project, and this was originally work that was done in the Tor browser. And like I described, it partitions the cookie store and it prevents cross-site cookies. The challenge is that there are some applications that require cross-site cookies to work that are perfectly reasonable things to do. And so this was never enabled by default. It required some special actions to enable this in Firefox previously because it did break a lot of sites. So in Firefox 77, we added something called dynamic first-party isolation. And this has been greatly improved and is now enabled whenever you enable strict mode since Firefox 86, which just came out. And that's what we're kind of branding as total cookie protection, along with the super cookie mitigations in Firefox 85. So what dynamic first-party isolation is it provides dynamic exceptions. And this is based on essentially assessing there's some ML stuff going on here to assess why a cookie is being set, and there's also some like known whitelisted domains as well. And what this is really useful for is things like SSO. So a lot of sites might integrate a third-party SSO provider, like signing in with Google or signing in using something like Auth0. And in those cases, it is necessary to have essentially a cross-site cookie, so that a cookie can be set on the authentication domain that does a federated sign-in, and then be read on the first-party site to authenticate you. And so this work greatly improved website compatibility and essentially eliminated almost all of the breakage that occurred due to first-party isolation. And so with that, we've added total cookie protection as of Firefox 86, and this gets enabled whenever you set strict mode for ETP. And then those things address things like fingerprint or device fingerprinting to some extent, and cookies for tracking. But to address some of the network eavesdropping, we have an additional feature called DOH, or DNS over HTTPS. And to understand how this feature works, I'm going to talk a little bit about DNS basics, and then we're going to get into the DOH basics, and we'll talk about how this protects you and why we did this. So a lot of you may be familiar with DNS already and how it works, but just really broadly speaking at a high level, whenever you make a DNS request, so you try to visit example.com in your web browser, if your local resolver or the resolver you have configured for your system doesn't have an address for that domain cached, it has to go and do what's called a recursive lookup. And what that essentially involves is that you first look up the root name server for .com, and then you look up for the authoritative name server for example.com, and then you ask that authoritative name server for example.com's address. Due to that, and the results cascade back down to the client that's requesting. And due to that, multiple endpoints on the internet are exposed to the fact that you've requested example.com, and any network along the way can see that you've requested example.com because it's all sent in plain text. Additionally, because DNS requests are typically unencrypted, what happens is there's something called DNS hijacking, and it used to be relatively commonplace with some ISPs in the United States and some other countries where they specifically hijack the NX domain response. So if you go to a domain that doesn't exist, rather than it telling your browser that domain doesn't exist, it would forcibly redirect you to a site filled with advertisements or a search page or something of that nature. So you can actually manipulate the results because it's unencrypted and it's unauthenticated. So in order to solve for this, you need to encrypt DNS. And there are a couple of different methods to do this, but one of the methods which Mozilla worked to help standardize and we implement in Firefox is called DOH, DNS over HTTPS. And like I said, it's been a ratified standard since 2018. Because it layers on top of HTTPS, it benefits from all the HTTPS standardization and improvements as well that happen over time, and it basically just gets them for free. So this includes things like new standards like TLS version 1.3, HTTP 2.0, and things that are upcoming in the future. Because DOH is encrypted using TLS, it has all the same benefits that anything else encrypted with TLS has, which means the traffic that's sent for these requests can't be seen or eavesdropped on by intermediate networks. Additionally, it can't be manipulated by intermediate networks. It basically provides it immunity to man-in-the-middle attacks. So there's no way to basically hijack that. Additionally, something that I didn't write down on the slide, but is interesting, is that the TRRs that Mozilla is using in Firefox today for our current DOH rollout introduced another feature called QName minimization. And what this does is instead of having the client make request to each name server and provide the full request each time, it breaks the request down to just what's required from that name server as you're recursing to get the result back. So if you were to do the same example as before, you go to example.com and you need to resolve that. Instead of having your recursive resolver tell you, hey, here's the root name server, go ask it who owns .com, and you say, hey, I need to know about example.com, you just tell it, hey, I need to know about .com. And then the next one you say, hey, I need to know about example.com, and you get an address back. So it reduces your exposure. And because the TRRs that we are utilizing take requests from a lot of clients, they have a much higher level of domains that are cached. And so the number of requests that result in recursion is also lower as well. But this is very helpful, especially if you're on a public network, which might have user hostile tracking on that network. For instance, some public networks like hotel Wi-Fi internally are serviced by companies that do tracking of people's browsing behavior at the hotel, and they sell that data to advertisers. If you're using DOH, that defeats one of the main methods they use to track people's browsing habits. And part of this is trusted recursive resolvers. So it's not enough to just have an encrypted protocol. You also need to trust that the DOH endpoint you're connecting to is going to treat you fairly as a user and respect your privacy. And so Mozilla has started a program called the TRR program, the Trusted Recursive Resolver program. And essentially it's loosely modeled after how we work with certificate authorities for TLS certificates. Each provider in the program is vetted by Mozilla, and we sign a contract with them called the TRR agreement. And that contract has a lot of limitations about what that provider can do with user data, what sort of data they can collect, how long they can keep it, what sort of logging they can perform, and it has some technical requirements that their DOH endpoint must meet. In addition to all of that, we also require all of our providers to publish yearly transparency reports and to undergo third-party audits every 2 years. And those audits help to validate that they're still following the agreement that they agreed to and that the contents of the transparency reports are accurate. So if you combine DOH with TRRs, you end up with a very private DNS experience, which is not a complete defeat for all forms of network eavesdropping, but it defeats one of the most common forms of DNS or of network eavesdropping. And it also defeats DNS hijacking. So in Firefox, we've now enabled DOH by default for the US. We started our rollout last year, and by the end of 2020, it's now enabled by default for all US based users. We're still working on rolling out to other locations globally, but right now it's just in the US. How it works though is users can it's opt-in by default. Users can opt out. They can do that through their settings, or network providers can opt out by either setting an enterprise policy or setting a canary domain on their local resolver. But if you want to make use of DOH, and I recommend that you do, we also support enterprise policies for DOH. And this allows you to do a couple of things. One, you could set up a DOH endpoint for your internal directory servers if you use something like Split Horizon DNS or Active Directory. You could put a DOH endpoint or DOH proxy in front of that resolver, and you could use DOH across your own networks. And the enterprise policies allow you to set the DOH endpoint the Firefox makes use of. But another thing that you can do is you can set a list of domains that are excluded from DOH and are forced to go to the local resolver. So you could exclude your corporate domain and allow DOH to be used with a public resolver for everything else online. And this would also allow you to use Split Horizon DNS while having DOH enabled. So there is a pathway to make use of this in your organizations to help protect your users' privacy and to ensure that their privacy is protected when they exit your corporate network to travel as well. Next, I'm going to talk briefly about some of the upcoming features that we're going to be adding to Firefox to help increase tracking protection and increase user privacy. Note, both of these features are not yet released. They actually are based on standards that are still undergoing work that have not yet been ratified, but are in progress. So this is kind of a sneak peek. So you can't enable these today. The first is called Encrypted Client Hello, or ECH, and it builds off of an earlier standard you may have heard of called ESNI, or Encrypted Server Name Indication. And both of those standards were built to solve the SNI leak. ECH goes a step further and it encrypts the entire client hello. And so essentially, when you go to make a TLS handshake, the first part of the TLS handshake happens in the clear, because until the handshake's completed, there's not an encrypted connection. And the very first part of that handshake is the client sends to the server a message which contains a object called the client hello object. And the object contains a field called the SNI field. And that field basically says the domain that you're visiting so that the server can retrieve the correct certificate to return to you. And that's because a server might host, hundreds of websites, and therefore it needs to know which certificate to return. As part of that, ECH basically encrypts that entire client hello object, and it extends it by creating a new object called client hello inner that exists within the client, which is the encrypted part that exists inside of an unencrypted client hello object. So if the server supports ECH, it can decrypt the contents of client hello inner, and it'll proceed with the connection that way. If it can't, then the client hello outer provides essentially a faked SNI that servers which have TLS 1.3 support understand, and it will return back the correct public key so that the client will drop its connection and reconnect using a correctly encrypted client hello inner. How it gets the key is a little technical, but it's based on a new record type called HTTPS service. And this essentially contains the public key. And the encryption is using something called HPKE, hybrid public key encryption. And this is also a new standard. So there's several new standards involved here in making ECH work. But it's really an impressive technical feat and something that I think will greatly increase privacy online. And it also relies upon DOH because DOH allows for the DNS request to be immune to tampering across the network and immune to certain types of cache poisoning attacks. So whenever you do the HTTPS service lookup, record lookup, that has to happen over DOH. So whenever ECH becomes available in the browser, it will only be active when DOH is also enabled. So there are some tie-ins there. But yeah, it's still being worked on. It's not quite ratified. It's on like draft number 10, but it's really cool, and I think it's going to make the future much better for users. Second thing I want to talk about is Oblivious DOH. And Oblivious DOH addresses one of the concerns around centralization and data access that still exist in the existing DOH framework with TRRs. And what it does is essentially it has two separate providers involved in every DOH request that uses ODOH. The first provider acts as a proxy, and the second provider acts as a resolver. And this ensures that no single provider has all of the information that's contained within a DOH request about the user. And essentially, the resolver doesn't see the user's origin IP address, and the proxy doesn't see the domain that you're requesting. Where today, if you make a DOH request, while you are talking to a TRR within Firefox that's signed an agreement about how your data is handled, you're still sending them a request that says what address you're trying to visit, and of course, it comes from your IP. With ODOH, that resolver just sees a request coming from a proxy that proxies for thousands or millions of users, and doesn't have any way to uniquely identify which user made the request. And by the same token, the proxy has no awareness of what request you're making. It just knows where the request came from. And so this in conjunction with our other work provides a very private experience online for users browsing. And this is a very early standard. It's on the second draft, and it has also not been ratified. So this is actually not even enabled except in like test builds. It's still undergoing testing even for interop and stuff. So this is like super early, but it's a very exciting technology that I think will help make the world a better place. So in conclusion, trackers are pervasive. They're everywhere. So if you're using the web, there are companies and other entities online that are tracking that behavior. And that has privacy implications, as well as increased risk for NGOs and nonprofits, because you may be working with vulnerable or marginalized communities or in politically contentious situations. But there is hope, because Firefox is leading the way to improve the world that we live in and the way that we interact with the web. And part of that is through new standards and technologies, and part of that is through building a default experience for users that is respecting their privacy and understands, you know, the value that privacy brings online. And with that, thank you to all the folks that joined, and also thank you to my previous presenters in this webinar series. And if you click this link in the slides, or you go to this link, you'll be able to get a copy of Firefox downloaded for free. And with that, I'm open to questions. May, did we have any questions on the YouTube stream?
Currently, no questions.
Okay. If you do have questions, feel free to just drop them in the chat. Drop them in the chat in Zoom as well, and I will address those. Any questions in the YouTube chat?
Just got a question that says, any links to learn more?
Sure. Yeah, actually, I believe May confirmed for me the slides should be shared publicly after the fact.
Yes.
So in the speaker notes on all of my slides, I have references for the statements that I make. Some of them are kind of off the top of my head in the slides, but I pulled up some references to support those statements. And so there's a plethora of links within the speaker notes that have links to like academic papers and other articles in the public space that talk about this stuff in more detail.
Just to build on that, I will look out for an email with links to the webinar recordings as well as the presentations. So more content will be available for sure.
Any other questions?
Nothing in YouTube right now.
Okay. Well, thank you all. I appreciate you coming to the webinar, and I hope that it was valuable information for you. Please give Firefox a try.